Hello everyone, myself Pragna from Sri Venkateshwara College of Engineering today about to present you about the design and analysis of algorithms. What is an algorithm? An algorithm is a set of step of operations to solve a problem, performing calculations, data processing, and automated reasoning tasks. An algorithm is an effective method that can be expressed within finite amount of time and space. Designing of algorithms. The important aspect of algorithm design includes creating an effective algorithm to solve a problem in an effective way, using minimum time and space. To solve a problem, different approaches can be followed. Some of them can be effective with respect to time consumption, whereas other approaches may be memory efficient. However, one has to keep in mind that both time consumption and memory usage cannot be optimized simultaneously. If we require an algorithm to run in less time, we have to invest in more memory. And if we require an algorithm to run with less memory, we have to invest in more time. Let's see some of the characteristics of algorithm. Algorithm must have a unique name. Algorithm should have explicitly defined set of inputs and outputs. Algorithms are well ordered with unambiguous operations. Algorithms halt in a finite amount of time. Algorithms should not run for infinity. That means an algorithm must end at some point. Let's see about the divide and conquer technique. The divide and conquer recursively solves subproblems. Each subproblem must be smaller than the original problem, and each must have a best case. A divide and conquer algorithm has three parts. Divide up the problem into a lot of smaller pieces of same problem. Conquer the subproblems by recursively solving them. Solve the subproblems as base cases if they are small enough. To find the solutions to the original problem, combine the solutions of the subproblem. Let's see about the merge sort. Introduction. Merge sort is divide and conquer algorithm that was invented in 1945 by John von Neumann. It's one of the most effective sorting algorithms with a time complexity of omega n log n in the worst case. In this PPT, we will discuss the topic and concepts of implementation of merge sort. Merge sort, a sorting algorithm that works by dividing an array into smaller subarrays, sorting each subarray and then merging the sorted arrays subarrays back together to form the final sorted array. How does merge sort work? Merge sort is a recursive algorithm that continuously splits the array in half until it cannot be furtherly divided. That is, the array has only one element left. An array with one element is always sorted. Then the sorted subarrays are merged into one sorted array. Here is an example of merge sort, where an array of four elements is given, which is divided into two equal halves by finding out the middle element of the set of array, and then they are divided into each single parts, and they are arranged in ascending order and arranged back in the same array order. Algorithm for merge sort. This is then algorithm for the merge sort, where mid is found by adding beginning plus end by 2. The important part of merge sort is the merge function. This function performs the merging of two sorted subarrays that are a beginning to mid and a mid plus 1 to end to build one sorted array a beginning to end. So the inputs of merge function are a array beginning, mid and end. Code of merge sort. So this is the code of merge sort. This is a Java code which, when used, can be obtained the merge sort pseudocode. This is the pseudocode for the merge sort, where if right is greater than left, find the middle point to divide the input into two halves, where middle is equal to left plus right minus left by 2. The second step is to call the merge sort for the first half, where input left and middle. Call merge sort for the other half is the third step, where input middle plus 1 and right is called. Merge the two halves sorted in step 2 and 3. Input left, middle and right. Let's see about the merge sort complexity. The merge sort complexity has time complexity. Case time complexity has best case, which is theta, average case, which is, and worst case, which is omega. Time complexity of merge sort. Now let us follow up the steps. Our very own first step was to divide the input into two halves, which is compromise as of logarithmic time complexity, that is log n, where n is the number of elements. Our second step was to merge back the array into a single array. So if we observe it in all the number of elements to be merged in. And to merge back, we use a simple loop which runs over all the n elements, giving the time complexity of omega n. Finally, the total time complexity will be step 1 plus step 2. This is the general analysis of merge sort, where time complexity, the best case, worst case is found using this. The best case of merge sort is n log n. Let's see the applications of merge sort. Sorting large data sets. Merge sort is particularly well suited for sorting large data sets due to its guaranteed worst case time complexity of omega n log n. External sorting. Merge sort is commonly used in external sorting where the data to be stored is too large to fit into the memory. Custom sorting. Merge sort can be adapted to handle different input distributions, such as partially sorted, nearly sorted, or completely sorted data. Merge sort is useful for storing linked list in omega of n log n time. Merge sort can be implemented without extra space for linked list. Merge sort is used for counting inversions in a list. Merge sort is used in external sorting. Let's see the advantages of merge sort. Stability, guaranteed worst case performance, and parallelizable. Stability. Merge sort is a stable sorting algorithm, which means it maintains the relative order of equal elements in the input array. Guaranteed worst case performance. Merge sort has a worst case time complexity of omega of n log n, which means it performs well even on large data sets. Parallelizable. Merge sort is a naturally parallelizable algorithm, which means it can be easily parallelized to take advantage of multiple processor or threads. Let's see the disadvantages of merge sort. Space complexity, not in place and not always optimal for small data sheets. Space complexity. Merge sort requires additional memory to store the merge subarrays during the sorting process. Not in place. Merge sort is not an in place sorting algorithm, which means it requires additional memory to store the sorted data. This can be a disadvantage in applications where memory usage is a concern. Not always optimal for small data sets. For small data sets, merge sort has a higher time complexity than some other sorting algorithms, such as insertion sort. This can result in slower performance for very small data sets. For smaller data sets, merge sort is slower than other sorting algorithms. For the temporarily array, merge sort requires an additional space of omega n. Even if the array is sorted, the merge sort goes through the entire process. So these are the disadvantages which we face during merge sort. Thank you.